There we go. That looks like everything's running there now. Okay, so let's go ahead. So we're gonna go through people's couplings or teams couplings one by one by one. And what I'm gonna do is and I'm gonna stop my video just to decrease the amount of bandwidth that I'm using up here. And 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 I see we've lost that other side camera again. That's okay. Um, I'll weigh everybody's or each team's coupling, and then I'll stick it in the device, and then we'll test it, and we'll record the weight and record the maximum load. So let's see here. Let's start with team number one. It's always a good place to start so you can kind of see team number one's coupling there. Now let's turn on our scale first. That would be helpful. Let it tear. Okay, so team number one's coupling is these three pieces together. And as you'll see, we've got a weight of 35.3 grams now that things have stabilized. So I'll enter that 35.3 for the weight. Okay. And you can kind of see the way that the coupling goes into the assembly here. The bottom. Yes. Go ahead. Oh, you can see it now? Okay, great. I think, yeah, okay, great. Yeah. Let me know if it cuts out again. So 35.3. So let's stick this in here, making sure that we get all the pieces correct. So we need to bring this crosshead down a little bit. There we go. You'll see it slots in very nicely like that. And then this goes in one side and this goes through the other side like this. Okay. Now, this doesn't seem like it's been printed to be quite long enough, right? Because these two pieces should be connecting like this, but if you look at the length here, you'll see that they don't quite meet. So no point including this, and we'll have to rely on just the connection there. So let's go ahead and test that component as it is. And anybody that's on a team here, when I'm inserting your coupling, if you see that I'm not putting it in the connectors properly, just let me know. Okay. So let's run the test for this one and see how things turn out here. Okay, I'm going to go in here and slow this loading rate down a little bit so we're not pulling too fast here. I think 10 millimeters per minute is maybe going to be a little bit too fast. So we're going to slow that down to a crosshead speed of 8 millimeters per minute. Okay, great. All right, let's see how it goes. Now, just before I do that, I'm just going to make sure that we're starting from a condition of there being zero load. You can see down on the bottom of the panel here that there's zero load. So we're all good to go. Okay. All right, you can see that that it's the edges there of that coupling that have really made contact now and are giving us that increase in force. And you can see that we're well above the 2 kilonewton mark already. And obviously we can see where the point of failure is going to occur there with those pieces on the sides being sheared off. Now let's see if we can make that a little bit better for you. Okay, so the sides have sheared off on that one now, so we can stop that test. And we'll return it to 0. Okay, so we had a peak load of 4.9 kilonewtons there. Again, 4974. All right. Okay, let's pop that one out, and then we'll get the second group set up. These can be a little tricky to get out. There we go. Okay, group number 1, well done. Okay, group number 2. Let's look at what group number 2's coupling looked like. Group number 2, here it is. It's kind of a, well, like sort of, I don't know what you call that shape. Upside down, sort of, it's like a fork shape, really. And it's got what? Looks like, hard to tell where the pins are meant to go here, but it looks actually, now that I've got the coupling in my hand, we've got 1 big pin and 2 on the sides there. So let's weigh it up, and we'll get it weighed and inserted. Okay, and a couple of pins, make sure that those are on too. So what have we got there? 21.7 grams. 21.7. 21.7. Okay, so it's going in like that. See if we can get all of these pins through. There's one to start. from the other side here. There we go. A little bit of persuasion with the hammer. And now we get the two smaller ones in, so the big pin should go in, and it has. Perfect. Okay, we have the weight recorded, 21.7, and now we can start the test here. So group number 2. Okay, up to 1 kilonewton. 2 kilonewtons made the mark. There we go, nice dramatic failure. So we had a failure in normal stress right at the location of those 2 pins where the cross-sectional area of that vertical piece was reduced. Okay, so a peak load of 3,564. 3,564. Okay, nice work, group 2. So if you're going above the 2 kilonewton mark significantly, that's obviously an indication that you could have taken away a little bit more material than was taken away. But you know, three and a half relative to 2, that's good. Okay, let's look at group number 3 here. So group number 3. Okay. See that there's this nice square piece with these cross bracings in the center, and then 3 pins holding it at the top. So let's see. We've got a total mass of 17.7 grams, 17.9 grams, sorry. 17.9 grams. $17.9 grams. So that's our lightest one yet. Group number 3. Making sure that I save this file where I'm recording the weights before the computer crashes and I lose it. Okay, so let's see how this goes in. So we've got to bring down the crosshead here. Now, before we put this in, let's make sure that we're at 0 load still. Yeah, we are at 0 load. That's good. Now you can see this one's going to be a bit snuggly here, so we're going to bring this a bit lower. There we go. Okay, let's see if we can get these pins inserted. Oh, that one went in nicely. Number 2 in nicely. Number 3 in nicely. Okay. We're all set up here. Okay. Two kilonewtons, there we go. This is great. 4 kilonewtons. 5. And coming back down. So what, oh, you can see the spot where failure is occurring right in there. There we go. So straight up tensile failure, normal stress there. Okay, return to 0, no. So what do we have? Peak load, 5,947. 5,947. Okay, let's pop this out. There we go. Okay, next up, group number 4. Let's see what number 4's looked like. Okay, number 4, we've got a little I-beam here that goes through. So that one is going to be a light one. Here you can see it in physical form there. Okay, and 2.4 grams. Wow, light. 2.4 grams. Okay. All right, let's see how it does. There we go. Now I'll make sure that it's nicely positioned right in the center there. Okay, good. Okay, here we go. $14, $15, $16, $17, $18. Oh, so close. And you see that we've got shear failure at the bottom are occurring there with those flange pieces of the eye shape. Heartbreaking. 100 newtons shy. That was a good attempt. The factor of safety on that one was just maybe a little bit too narrow. Okay, let's record that. 1890. Okay, group number 5. That was a great attempt. That was a heartbreaker. 2.4 grams. Can't get much lighter than that. All right. Now we've got group number 5. Let me collect the pieces here and then we'll take a look at what this looks like on the screen. Okay. Interesting shape. Let's weigh it up and we'll see what we've got here. Okay, there it is. Okay, and then we've got a whole mess of pins there. 24.6 grams. Let me record that. 24.6 grams. 24.6. Okay, so we've got 2 long thin pins and 3 shorter, larger diameter pins, and it looks like the 3 larger diameter ones go on the top and 2 shorter ones go on the bottom. Go straighten that out. Slide this in, and this needs to come down just a little bit more. There you go. Now, these larger diameter ones, we'll bring that down a little bit more. Oh yes, good point. Actually, you know, because the pin is going through that bottom hole, and it is supposed to go through the second that. Yeah, yeah, that makes more sense in terms of a design. There you go. Good one. Glad you unmuted and stopped me. I probably would have figured that out before pressing the play button, but you never know. There's a lot going on here for me to concentrate on. So, all right, and those pins are fitting through very nicely. So well done. Okay, look at that. It's an attractive looking assembly, isn't it? All right, let's see how it does. Flip that button. There we go. Now we're ready to go. Two. Whoa. Okay. There we go. We had a break right up there. You could probably see that in the video. Return to 0. No. Okay. Let's look at that. 2,443. Man, that is getting pretty close to 2,000. Well done. Well done indeed. Group number 5. Let me record that. 2,443. 2,443. All right. There we go. Okay, group number 6. What do we have for group number 6 here? Group number 6. Group number 6 is another small sort of I-beam, but you can see that they've gone even further and reduced the material that would have been present in this slot going the other way in the design, since that wouldn't be under any sort of load. So that's been taken out too. So let's see what this one weighs. Should be around the 2.4 mark, like the other one. Okay. You can see it in its physical form there. Okay, 3.2. This one. Give that another weigh just to make sure. 3.1 this time. We'll go with 3.1. 3.1, group number 6. Okay. Now, I want to make sure that this is right in the middle, because that's very important for this design. Okay, that's got it there. Okay, deep breath, deep breath. Group number 6, here it goes. '16, '17, '18, '19. Oh, 2,000, 2,300, 2,400, 2,500, 26, 27. And what are we getting? We're getting some shearing right at the top. So what did we get to? Peak load of 2.79, almost 2.8 kilonewtons. Well done. Well done. Incredible. 2792. 2792 with only 3.1 grams of PLA used. Now that is some efficient engineering right there. Okay, let's see. Yeah, we were starting to get a couple of cracks down low there, but yeah, a couple more cracks on that side. But overall, very good. It was a good choice to make these as on the bottom here, this sort of thickness. Right, very nice, very nice. In the garbage bin. Okay, number 7. Do, do, do. Let's see what number 7 looks like. Group 7. Okay, group 7 went for it all. We've got, or almost it all. I didn't use all 3 pins on the lower section, but used 2 of them, as well as a piece that's going to take up most of the lower hull connector there. 4 pins on the top. Okay, it's going to be a weighty one, no doubt. Let's see, there it is, number 7. Okay, and the pins. 36.3 grams. 36.3. Okay. That in there like that. Now we'll do the big pin to start with. Okay. There we go. That goes in nicely. And then the 3 pins at the top. 1, 2, 3. Make sure that pin's nice and centered. And then 2 pins at the bottom. There's 1 pin. There's 2 pins. Great. All right, everything's in. Let's see how it fares. Okay, it's met the 2 kilonewton mark. Still going up. Ding, right? So right in the plane of those 3 holes where there's a reduced cross-sectional area. What have we got? 3,235. Okay. Nicely done. Group number 7. There you go. You can see that there, right, where it broke, where there's the less material there in the cross section in the plane of those 3 holes. All right. Dong. So what does that bring us to? That brings us to group number 8. How much did it weigh? 36.3 grams that one weighed. Okay, group number 8. There we go. Now, you can't really see it too well here, but we've got 3 different pins and sort of a plate that goes through the middle. See it a little bit better in a second. Here we go. There's the plate that goes through the middle there. And then we've got 3 pins that go with it. Total of 7.1 grams. 7.1 grams. There we go. 7.1. Great. Okay, so the small part goes downwards with the 2 pins through it, and those pins go in the top and the bottom holes. Reminding myself, looking at the drawing. Yep, that'll work. Come down a shade like that. There we go. Let's get that one in now. And the bottom one, it's nice and easy. Okay, and the top. Now, I'm going a bit blind here as far as where this hole is. Okay. Should be right about there. Let's see. Nope, not quite. Okay, let's get this. Go. Make use of another phone here to take a peep at that hole. It's like it should be pretty much going through there. Try giving it another little tap. You know what we'll do? This is a smarter idea. since we can see these bottom pins really easily, let's get the top one in first. That's a much better idea. Tight fit there. There we go. Now let's bring it down. Okay. Just need to give this a push into where it needs to be. Let's get a different tool for that job. Oh, this one won't be fine. Okay, perfect, it's in. Tricky one. All right. Let's go for it. Here we go. Now, part of the difficulty when you have something like this is that because the pins are very long, they're going to experience a lot of bending, and you can see them bending upwards now. $500. Okay, we're still increasing a little bit, but we're kind of unlikely to get too much more load of this one, but we'll still let it run and see how it goes. And of course, when you did the lab experiments involving the bending stress lab too, you saw how flexible long pieces of this PLA are. Now you can see you're starting to get some breaking down there in those pins. Okay, we've lost one on that lower left-hand side. There we go. We've lost the upper one on the left-hand side too now. Okay, and now we're starting to come down and load again. All right, so this one's done. Turn to load, no, 0. Okay, so we had 649 newtons. 649, there we go. Perfect. Okay, let's take this one out of here. Okay, number 9 next. Number 9 next. Number 9, number 9. Group number 9. Okay. Group number 9 looks a little bit different than I had there. So we'll see what it looks like here. Here's group 9. As you can see, it is a big honking piece of PLA. All right, so let's see what that weighs. And we'll add all the pins and make sure everything's on here. So what do we have? 70.3. 70.3 grams. Okay, let's try and get this thing in here. All right. There's the top pin and bottom pins. Let's see. Oh, that went through nicely. 1, 2, and we'll tap, tap, tap. There we go. 1, 2, 3. Let's see how we do. Okay, so we are certainly not going to get a tensile failure through the center there with that very large cross-sectional area. We'll probably, we'd likely get tensile failure maybe through this location here where we get the change in cross-sectional area, or right here. We've got a really big pin plus these little flange pieces hanging out here to take the load on the top. So yeah, probably most likely at the bottom here we'll see failure due to normal stress. But let's see. Should take well over 2 kilonewtons. Now we did see normal stress failure at this location here at 2,400 newtons in another group. So now I heard something break. I don't see anything. We're up at 6,807 kilonewtons. 7.5. Bam. All right. There we go. Okay, what did we have? 7,579. 7,579. Nice loud dramatic failure there. Oh, you can see actually that first crack, let me see here though, so I can see the screen. That first crack that we heard would have actually been this piece. So the pin was pulling upwards like this, and this piece broke in two pieces. So that first failure we heard was a break straight down the middle, breaking this into two pieces. But that didn't affect strength too much because it was still held on by this little flange down there, and then that held on until we get the normal stress failure. There we go. Okay, goodbye. Number 10. Here we go. It's number 10 here. There it is. Okay, and we've got a few different pins here. 3 pins for the top and 3 pins for the bottom. There we go, we've got them all on the scale. 41.2 grams. Forty-one point two. 41.2. Group number 10. There we go. Now, how does this fit in? Okay, it's easy. Now let's just make sure we're starting from 0 load since we're having to bring this down really close into contact here pretty much with the lower support. So we're still at 0 load. So we're starting from a fair point. All right, nice. Okay, on the top, we've got 1 big one and 2 smaller ones, 1 there and 1 there. Okay, those are fitting in nicely. And then on the bottom, we've got 3, so it's no difficulty figuring out where these go. Just getting these long pins through these threaded all the way through is sometimes a little bit challenging. Oh. There we go. Okay, it's in place. There we go. And you can see, in order to get that one in, these actually had to make contact a tiny bit. So that's why we're registering a load of minus 350 newtons right now, because the load cell at the top is actually in compression a little bit. So let's go ahead and run this one. Right, so you see we come up from a negative load to 0, and then we flatten out, and then we start getting some tension there. Okay, we're up above 2,000. All right, nicely done. All right, failure Failure right in here. So 3,637. 3,637. All right, group number 11 next. What was the force on that one? It was 3.6 kilonewtons. 3.6 kilonewtons on that one. Okay, group 11. Okay, you can see group 11's here, right? Let's go over and find it. Here it is. There it is. Group number 11 and a couple of pins as well. 7.9 grams. 7.9 grams. Okay. Whoops. Going to be a little bit of a tight fit again, so I'm just going to make sure we've got clearance between these two and then check to make sure that we are starting at a load of 0, which we are. Okay, bring these close together again. There we go. Okay. Larger diameter pin is going to go at the top. That one's through. That was nice and easy. And the smaller one at the bottom. There we go. Nice fit. Great. Okay, let's let it go. Here we go. One kilonewton, 1.2, 3, 4. Oh, what did we have happen there? Okay, what did we get to? Peak load of 1,538. 1.5 kilonewtons, 1,538. So let's explore that. Okay. Just not enough cross-sectional area right in the middle there. Okay. Now, let's lower the blind in the lab a little bit and try and cut out some of that direct sunlight. Our clouds have just sort of parted a little bit here. We're getting a lot of shadows there. There we go. That'll be better. Okay, where were we? That was group 11. We're on to group 12 now. Okay, I don't have a picture of group 12s. Let's see. I do have group 12s here. So you can see it here. Interesting shape. Okay, scales at 0. And to go with that, there are a couple of pins as well. Voila. 23.7 grams. 23.7. 23.7. 23.7. There we go. Entered in the spreadsheet. Okay, let's put this one in. Okay, now I'm just going to again make sure that we're starting from condition of 0 applied load. Okay. Now, which hole was this bottom one going through? Okay, it was going through the center hole. So I think I will do that one first. Let's see. Okay, good. You see it kind of poking out the other side there. And then the big pin in the top. Tap, tap, tap. Good, that's in place. Perfect. So we're ready to go. Okay, very nice. Very nice. Return to 0, no. So what do we have as peak load there? We had a peak load of 2,565. 2,565. Nicely done, group 12. So playing it pretty close to that 2 kilonewton mark that you were aiming for. Okay, now gotta get this thing out of there. Now I'm gonna need something to tap that out with. Let me see what we have kicking around here. There we go. So that was group number 12. Okay, we're moving through them. Group number 13. Group 13, group 13. Okay, group 13 has an interesting design. Sort of this cruciform shape on the bottom, and then it twists a bit into a other cruciform shape on the top. Okay. Let's see here, and there's all kinds of pins. Pins in every hole in this one. Okay, so here you can see the actual look of the printed component. So let's weigh this. 22.1 grams. 52.1. Okay. Now, take out all of these pins. Great. Okay. All right, so this one is going to be so this one's difficult because, right, let's see, we can insert that in the top there and then drop it down. Okay, need to be strategic about getting that one into position. There, had me fooled for a second. Okay, there's the top portion. Now the bottom portion is being made wide enough to maximize the fit in that slot, but we're still going to have the problem of the pins experiencing fairly significant amount of deflection on this one. And of course, the problem for me, again, of locating where exactly the holes are for this. I think it goes almost to the bottom. There we go. Okay. So now we'll just give this a little tap. Okay, we've got the bottom pin in. You've got one in, the rest go pretty easily. There we go. It's in. So 22.1 grams for this one. Let's see how it does. We're at 500 newtons, 600 newtons, 7, 8, 9, 1 kilonewton. Curve starting to level off a bit. These pins are really bending upwards there. We might get a little bit of extra load out of it. Maybe 1200. $1,300. Not sure that it's going to get to 2,000. Here we go. Yeah, and we're done. So peak load, 1,340 newtons. 1,340. All right. And group number 14. There we go. Final group, we have a part 4. So group number 14, as you can see here, basically took the strategy of let's make it to past the 2 kilonewtons and let's not worry about the weight too much. So the component fills the entire shape, right, including all 6 possible pins. Okay, there is group 14. And the pins that go with it. So we've got 49.3 grams. 49.3 grams. .3 grams. Group 14. There's one pin. Oh, let's tap these in as we go. Nope. 2 at once. Oh, there's the other one. Okay, and the lower pins. Okay, that doesn't want to quite go through on that side. Let's try it through the other way. There we go. It doesn't quite go through. See if we can get this one in. That one went in. The very bottom pin. That one went in. Let's try the top pin again. There we go. Let's make sure that pin's centered. Perfect. Okay, all set to go there. Group 14, here we go. There we go. We made it past the 2 kilonewton mark easily. Made it past the 4 kilonewton mark. 5. 6 kilonewtons. 7. Should have a good dramatic failure here for the final one. Always nice. So, what do we have? Let's see what our peak load was there. We had 7,459. 7,459. Right, for reference, that other one that we had that experienced a similar failure that was also a big component failed at 7,579. So pretty consistent in terms of load that is causing failure over that cross-sectional area there. All right, there we go. So let's make sure that's files saved there. Perfect. Okay, folks. So that is all the test files that we had, or all the groups that we had printed off to test.